All right, we're going to look at lesson 36, overcoming a third obstacle to factoring. What if there are no real number solutions? So our objective is I can identify equations or systems of equations in which there are no real number solutions, and I can graph them accordingly. So the opening exercise, the idea is to find all solutions to each of the systems of equations below using any method. So for this one, I'm going to use elimination. So I'm going to multiply this by 3 and this by -2. And the idea is, hopefully, I'm going to get rid of my x's. So I get 6x minus 12y equals -3. And then I get -6x plus 12y equals -8. So when I add these two, those all cancel out. 0 plus 0 equals -11, and 0 does not equal -11, so there's no solutions. Okay, let's keep moving on. Let's try this one. Y equals x squared minus 2. It also equals 2x minus 5. So I'm just going to set this equal to this. So x squared minus 2 equals 2x minus 5. X squared, I'm going to bring everything all into one side, minus 2x plus 5. And I get -2 plus 5 is 3 equals 0. So I'm looking for two numbers that multiply to make 3 and add up to -2. And that doesn't exist. There are no pairs of numbers that multiply to make +3 and add up to -2. So no real solution. Okay. And then finally, x squared plus y squared equals 1. And the same thing, x squared plus y squared equals 4. So 1 equals 4? No solution. Okay. Exercise number 1. Are there any real number solutions to the system y equals 4 and x squared plus y squared equals 2? So support your findings both analytically, that means do the math, and then graphically. So when we do this analytically, I'm going to substitute. I know that y equals 4, and I also know that x squared plus y squared equals 2. So I'm going to substitute that 4 in there. So I get x squared plus 4 squared equals 2. X squared plus 16 equals 2. X squared equals -14. And then I just take the square root of, so I get x equals the square root of -14. It doesn't appear to be a real solution. So now when I graph them together, and I'm going to switch over to Desmos really quick. I'm going to put these on here. Y equals 4. And then I'm also going to do x squared plus y squared equals 2. So there I have my two things. I wish they didn't use black. I wish they'd used another color. But anyway, you can see if I take that away and then put it back in, these two equations do not intersect. And a solution is where things intersect. It's either where they hit the x-axis, or it's where like a line hits a parabola or a line hits a circle or so on. It's wherever their lines or their paths cross. So if I'm going to sketch this really fast, y equals 4, and then this one. So I actually have a, it's like 1.4. It's the square root of 2 is what its radius is. Boom. Okay, no solution. Oh, good Lord. Okay, let me go back to the camera. So if I sketch that like that, my hands are not working very well. I just got in from the track meet, so I'm a little tired. Okay. All right, let's move on. Next page. It says, does the line y equals x intersect with the parabola y equals x squared? If so, how many times and where? So I've found with these, it's actually a little bit easier to graph this on Desmos and see what happens. So I'm going to go back to Desmos, and I'm going to get rid of these. And I'm just going to put in y equals x. And I'm also going to put in y equals x squared. Okay. So I can see from these two graphs that I've got a solution here and here. So I have solutions when x equals 0 and x equals 1. That's what my graph is telling me. So I just sketched that really quick on my paper. Okay. Now I'm going to go back to the paper and I'm going to solve this. Pretend those hit at the right spot. Okay, obviously my sketch is off. I have y equals x and y equals x squared. So that means x equals x squared. So let's set it to 0. I'm going to factor an x out of there. Okay, so what values of x would make this true? Well, this is true if x equals 0, because 0 times 0 minus 1 is 0. It's also true when x equals positive 1. And that's what we found. Pretend that's a 1. Okay. Just a bad sketch. Okay. Next one, does the line y equals negative x, so it's just going to be a line going this way, does it intersect the parabola x squared plus y squared equals 1? If so, how many times? Actually, that should be a circle. Solve analytically in graphs. So let's go ahead. I know that this is what y is, so I'm going to substitute that into this equation. So x squared plus negative x squared equals 1. So x squared, and that just becomes x squared equals 1. Sorry. So 2x squared, just getting ahead of myself, equals 1. So x squared equals 1/2. Stick with me here. So now I have to square root both sides. Okay, so x equals the square root of 1 over the square root of 2. So x equals 1 over the square root of 2. But we can't have a radical in our denominator, so we multiply this by itself, okay, in the numerator and the denominator. So I get x equals square root of 2 divided by 2. And if I were to get a calculator out, and hopefully I can pull this up pretty quickly, if I were to, I gotta turn my calculator sideways here, and hopefully we'll get this to work. Let me see here, square root, 2 square root. Okay, so 1.4 is the square root of 2 divided by 2, and you're going to get about 0.70 or something like that. Okay, I'm going to divide that by 2, and I get 0.707. Da 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 da. Okay, so if I go on to Desmos, so actually, yep. Okay, if I go on to Desmos and I graph this now. I'm going to change these equations. Y equals negative x and y squared plus x squared, equals 1. Okay, get that circle. And if we look, the x values where that occurs, it's at 2 places. It's at positive and negative 0.707. Okay, it does say parabola here, which is a little disconcerting because this is the formula for a circle. So not quite sure what they're looking for there. If it was a parabola, it would be intersecting back here. Okay, so yeah, we're just going to go ahead and say yes, it does intersect at those 2 places, here and here. Number 4. So this should be positive or negative. And I'm going to be honest with you. When we take the square root, I'm just still trying to figure out where the positive and the negative comes from on that. I'm going to have to spend some time on that one. This one, number 4, does the line y equals 5, which is up here, intersect with y equals 4 minus x squared? This is a parabola opening down. When you graph it on Desmos, it looks like this. So answer is no. Let's go ahead and set it up. Okay, so get everything equal to 0. 0 equals -1 minus x squared. Okay, and I'm just going to divide -1 out of both sides. So 0 equals 1 plus x squared. Good Lord, I'm brain dead tonight. Scratch that. This is what happens when I come in at night to make the video. Let's subtract 4 from both sides, and I get 1 equals -x squared. Sorry about that. Divide both sides by -1. Square root. Whoa, you cannot take the square root of a negative number. Not yet, at least. Not with real numbers, so no solution. Okay? All right, flip. So the lesson summary: an equation or system of equations may have one or more solutions in the real numbers, or it may have no real number solution. We've seen some of those. Two graphs that do not intersect in the coordinate plane correspond to a system of two equations without a real solution. So if they don't intersect, there's no real solution. If they don't have a real solution, the two graphs do not intersect. A quadratic equation in the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a does not equal 0, that has no real solutions, indicates that this does not intersect the x-axis. So it's going to be like a parabola up here or down here. Okay, it cannot go in these directions because those will hit the x-axis. So our exit ticket, I'm going to let you figure that one out on yourself. You're going to set these two up to equal each other, and you're going to graph it on Desmos and see what you get.